Good morning. So this is the year 9 about preparing salt. This is Mr. Henry Clement for preparing salt. So can I enlarge my screen? My screen seems small, you know. Okay, so I think that the admin has some time to solve the problem, but I think we can start now. So what is a salt? Maybe you are thinking of the table salt, which is the eating or flavoring table salt. We call it, that one is sodium chloride. Yes, table salt. Table salt. But other than that, we have many things, many other things also called salt, such as this one, calcium sulfate, which is a chalk, one type of the salt. Magnesium carbonate, yes, to dry your hand. Aluminum sulfate, to add to the dye. Ammonia nitrate, fertilizer. The copper sulfate to stop fungi growing on these soya beans seeds. So here we need to learn about acid and salt. Okay, we are preparing. We have 3 ways for this book. Okay, we have 3 ways to prepare the salt. Okay, one is called acid and metal, acid and carbonate, and neutralization. Okay, we will be learning these 3 for today. And now we are learning about acid and salt. Okay, the acid is important. Why? Every day, the chemical industry makes hundreds of thousands of the ton of the different salt. Okay, and many methods are making salt with acid. Okay, I'll let admin to help me to see whether I can announce or not. This is Mr. Henry Clement for your salt making. All acids contain hydrogen ion. Okay, the table below gives a formula of the 3 common acids that you can find in the laboratory. This table also shows some example of salt that can be formed with this acid. Okay, 2 other acids that you may meet are carbonic acid and citric acid. Carbonic acid is a weak acid that is formed when the carbon dioxide reacts with water. Salt are made from carbonic acid are called carbonates. Okay, so the citric acid found in the citrus fruit, such as orange and lemon, salt form are using, we call it the citrics. Okay, so can you find the common words here? A-T-E-S, A-T-E-S, but the in front is follow the same one. So now you can guess that hydrochloric, this is chloride, become a chloride. Sulfuric acid, sulfur, become sulfate. Nitric acid become nitrate. Can you see? This is IDE, ATE, ATE. So the hydrochloric acid, we have the HCl. Carbonic acid, we have the CO3 there. So become a carbonate, citrus. Here we have the sulfate to become a sulfate. This one we have the nitrate, so we have nitrate there. Okay, so the name will be changed a little bit of the spelling. Okay, so the main purpose of learning today is preparing salt using metal and acid. Okay, so if you have metal and acid, the reaction will be like you can produce salt and hydrogen. So this salt is a combination of these two. Okay. Okay, for example, this is the zinc. Okay. If you have the hydrochloric acid here, and then there's a zinc inside as well, so they'll react. Okay, until all of the zinc or hydrochloric acid finish. Okay, so the bubble will give out, which is the hydrogen. Okay. Making the salts of zinc sulfate. Be careful when heating and evaporating basin this, as the solution may be split and burnt you. Be careful. Pour about 50 cm of sulfuric acid into the beaker, the last beaker, can you see? Add zinc metal to the acid in the beakers. Once the mixture stops fizzing, pour into an evaporation dish. Heat the evaporating dish very gently until you see the crystal form at the edge of solution. Remove from the heat and leave for a few days to form the crystal. So this is zinc sulfate. Okay, let me have the paper. Okay, but I think you also know that this is like very dangerous. Okay, so I think instead of the beaker, sometimes if you can choose, the question asks you, you can choose a flask. Okay, this beaker. You pour in the acid, and then you put in the metal. But however, instead of using beaker, you can use this one. This is narrow at the mouth there. This is a flask. Okay, and then you pour in the acid, and then only you add in the metal. So you add a little bit, and then this one dissolve. It means that all the zinc is react with the acid. Okay, and then this disappeared. Then you add some more, and then disappeared. Then you add some more, and then becomes smaller. That means when the zinc becomes smaller and smaller, it means that there are still some acid there in this solution. Every time you add, you can see the bubble. Just like this picture. Okay, it means that the hydrogen is given off. You can collect the hydrogen so that to do a pop test later. But my purpose is that this you continuing add you continue to add matter until there is some piece of matter that are not going to disappear anymore. And then it shows that all the acid have been used. Okay, now. So now you need to have a filter funnel. Okay, and then you have a filter paper. And then you have a beaker. Yeah, now you can use a beaker. You pour in all the solution here, pour here. So can you see the remaining one, the black one, the zinc, will be filtered. And then all the filtrate coming in, the filter coming in is the salt plus water. And then you pour this one in the evaporation dish. Okay, and then you heat it. Okay, you heat it. Okay, heat, apply heat here. This is a tripod. So this evaporation you will evaporate the heat given will help the water to evaporate, and then once some solid appear, which is we call it in the saturated position. Okay, and then you turn off your heat and then leave this in somewhere to cool down, maybe for 1 day. And then you have some crystal form. Okay, now you go back to the filter funnel, a new one, new paper. Then you pour in all this in. So you can see the crystal form here. And then the filtrate will be there. So this is the, sorry, I think this is too long already. Okay, so this is the crystal salt we obtain. Okay, for example, if you are putting in zinc plus sulfuric acid, you will get zinc sulfate plus the hydrogen. The hydrogen is escaped already. If you are using zinc hydrochloric acid, then you produce a zinc chloride. Okay. If you are using magnesium plus sulfuric acid, if this is magnesium sulfuric acid, so it's a magnesium sulfate. If I use nitrate, if I use iron plus nitric acid, can you see the spelling? Sulfuric becomes sulfate, hydrochloric becomes chloride. So it will produce a iron nitrate. Okay. So if I use calcium plus hydrochloric again, see? So this calcium and chloride. So it will become a salt neem calcium chloride. Okay, now if I use a tin plus a nitric acid, it will become a tin 9 nitrate. Okay, let's see. Let's see. Okay, and then some are some. Okay, if somebody like this topic, allow me to get a book for you to refer with. Okay, just now somebody, one of you have asked about year 10, right? This is a year 10 book. I think I think most of school are using this book as well. I have a few copy of the different publisher, but I also prefer this book. Okay, so I think there's one student who are very good. Okay, can you see the whole book? It's about a typical so-called typical acid reaction. And then this 4 is the thing that run through the golden thread, run behind the chemistry books. So it's this 4 reaction. You are good, smart enough to ask this question, Oh, very good. So with metal, can you see acid and metal, acid and base, which is the acid and also base is a dry version of the alkaline. Okay, if the alkaline is dry, we call it base. Okay, because some rock they are not dissolved easily in the water, so we call it base. Okay, but other tend to resolve in the water, so we call it alkaline. And then we have the acid and carbonate, and then lastly we have the ammonium salt. Okay, which is the to produce ammonium salt. Okay, we have the calcium hydroxide and the ammonium salt. So they react together. Okay, so these are the 4. Okay, so this is a very important thing. Okay, to have to know this one. Okay, so just now the year 10, it means that do you mean that you want me to do a sharing on this, or you are going to join the tuition that I provide, or you want to get a free session? Let me know. Okay, let me know. I try to find one time. If you need anything, okay, just let me know. No worries. Okay. So then we come to the preparing oxide. Okay, because besides the metal and acid, okay, we also can use oxide. Okay, oxide. Some metal will not react with the acid to make salt. For example, silver and copper are too unreactive to replace hydrogen from acid. So they cannot kick out the bubble, the hydrogen bubble out. Okay, because they are so unreactive, Okay, so the way we need to do is just we need to find the oxide. Okay, so this keyword is very important. Allow me to find a word for you. Give me a second. Okay, never mind, later. I'll find it later. Okay, come. So to do oxide, let's see. Is it the same with just now one? Pour about 100 cm of sulfuric acid into the beaker as well. So if you don't want to use beaker, you can use mine as a flask. Okay, now. So these two, I change it. Okay. I use the flask here, but I use the beaker here. Just no, this one okay. This one is burning, right? Okay, this one is heating. So this one is a beaker. It's okay. Be careful. But I think the narrow one is to prevent the spill. Okay. So add the black copper oxide powder. Yeah, can you see the reaction is the same? Okay. Then heat the mixture gently, stir all the time. Do not boil the mixture. Okay. Don't boil, just heating slowly, okay. Gently, okay. Harmful fumes may be given off, okay, because the acid. When the mixture changes color to blue, turn off the heat and allow the mixture to cool. Filter the mixture, okay. The filtrate also of the copper sulfate pour into the evaporation basin, doing the same thing again. Okay, but be careful, it's the same. If you are using these two methods, okay, you cannot make sure that all the acid have been used. So when you're handling this, it will be very, very dangerous. Okay, so usually we will continue to keep adding on, adding until there is no more reaction, which is there is no more dissolve. Okay, you cannot dissolve anymore. That means all the acid is up. This is safer way of doing it. Okay. This book, I think, is just for you to learn the concept from the year 9. Okay, but this is very dangerous. Okay. So usually we will keep on adding the copper until there is no more can dissolve, and then we do the filter for the first time to remove this in excess. This is more than the acid can react to. And then this is a salt and water solution, salt solution. Then we heat it until saturated. What does it mean saturated? You can see when you heat the water will evaporate, Okay, evaporate little by little. And then when you see the water content has reduced, then you just use a rod. This is a ceramic, okay, tight. You just use a rod to pick up a little bit of the solution. It's watery, But once you pick up and you put here on the glass or the ceramic, immediately this one become a gel form, become a crystal. So immediately you turn off the heat and then remove it or just leave it there and let this and the salt to cool down by itself. This is so-called evaporating to crystallize the salt. Next, we can have metal carbonate with acid. Okay. So we have carbonate. Just like I show you from the year 10, 11 book, right? I think somebody is interested with that. Okay. So year 10, 11 book, you have this part. Okay. Such as calcium carbonate. I think the possible time, if you really want the year 10, 11, if you are, you can message me, let me know your needs. If you are not going to any homeschool center or school, and if you can also join this so-called weekdays morning session, I think we can discuss for that for a free session. So it may be on the Thursday or Friday, or if not, will be 8:30 maybe, or 8. Okay. So this is Mr. Henry Clements. Okay. I hope that you can learn well. Okay, and you can take this as a preview. You can take this as a revision. Okay, thank you for enjoying our session. Okay, so for this purpose, sometimes I will use my own drawing notes. Okay, I teach in many ways. Sometimes I have a lot of drawing notes. I think you have seen that. But sometimes I also will go through the textbook once thoroughly. Okay, so in my center, okay, I run the center which teach IGCSE program year 10, 11. Okay, usually I will finish the syllabus within 1 year, even though for 2 years, and then we'll guide through every page using at least 2 textbooks. Okay, so every year we are thinking which textbook to be used, okay, and then I will prepare the new approaching for the textbook. Okay, so I hope that you enjoy this class. So here, carbonate is something like calcium carbonate. Okay, a salt. Carbonate can be formed by reaction with the metal and carbonic acid. If you can get a carbonic acid, okay, then you can make the salt of the calcium carbonate. And here we are learning about using the acid and carbonate reaction. Okay, I think I show you also year 10, 11. Okay, this is the, I said that this is the golden thread to run through. Okay, the whole syllabus of the year 10, 11. Okay, the carbonate. So this is the general formula. Acid and carbonate, salt, water, carbon dioxide. Okay. So this is acid, carbonate, salt, water, carbon dioxide. You can see this is the general formula. Acid, carbonate, salt, water, carbon dioxide. If you have, I think the words must be calcium, sulfuric, calcium sulfate, and then this carbonate and will become a carbon dioxide. And then there's one more product which is the water. So you have the calcium here. So this is a hydrochloric acid. So calcium and hydrochloric will become calcium chloride. Calcium nitrate. So actually this is a limestone, or you can say or marbles, marbles. Okay, marbles. Marble is when you go to the shop, some dining table are made from marbles, right? Okay. So and then we have the coral skeleton are made from calcium carbonate as well. This piece of coral is reacting with the coral crystal. Can you see what is coming out? Is it the hydrogen? No. Hydrogen is for the previous one, which is the metal and acid. But this one is not. Okay. This one is water and carbon dioxide. So the gas forming is the carbon dioxide. Okay, I think this is a proper one, okay, as compared to the previous one. Can you see? Place, this is for to prepare the copper chloride from copper carbonate and acid. Okay. So 25 into a beaker, and then add a spatula of the copper carbonate, and then add more copper carbonate until they stop reacting. You should have a small amount of the unreacted copper carbonate left in the beaker. This is called adding excess copper carbonate. You make sure that all the acid have reacted. Yeah, this is the proper way of doing it. Filter the mixture. The unreacted copper carbonate, okay, will be trapped in the filter. Okay, paper, and then pour the filter into the evaporator dish and heat gently. Yes, be careful. Very dangerous, huh? And then start heating when you see some crystal, or you just pick up some and put on the towels, and then leave a few days to cool down to form the crystal. Okay. Yeah. In year 10, 11, you will be learning this in very detail. Can you see? This is making salt, starting with metal, starting with insolution base, insoluble base. Okay, can you see here? At the other extreme, the reaction of lead is with acid is too slow, and copper, silver, and gold if you're using metal, they do not react at all. Okay, so you need to use the oxide instead of the metal. So copper cannot be used, so you must use copper oxide. Can you see? Then we go to the last one today, which is the forming salt by neutralization. Okay, acid and alkaline. Okay, this is the third. Can you see? This is also one of the syllabus in your year 10, 11. Because now you're year 9 already, right? So here we have the acid and base, but here we divide into two types. Okay, one is called acid with hydroxide, which is alkaline. Another one is acid with the oxide, which is a base. So the difference between these two is just this is aqueous, this is solid, the insoluble form of alkaline. But the product will be the same, salt and water, salt and water. And then we'll be learning a lot with neutralization in your year 10, 11, okay, in the great detail. And also here, starting with alkaline, a soluble base. You can see we call it soluble base, alkali, or the base you can call it as a dry alkali. Can you see? The both way lah. So you need to add the acid and the indicator. So for example, here we use a phenolphthalein, so the thing will look pink, you know. So you titrate in a little by little the acid. The indicator has suddenly turned colorless. Yes, suddenly, you know. So the alkaline has all been used out, so the solution is now neutral. Add no more acid, because if you add one more dot of acid, then this solution will become slightly acid already. So record how much. Okay, and then you need to rinse and wash your flask. Okay, rinse for at least 2 to 3 times. Okay, and then you add the same amount of the alkaline and the same amount of acid. Okay, and then you add that, though this is a pure one, pure salt and water without the indicator, and then you do the same thing again. You heat it carefully, slowly, until some crystal form and left behind that, and then allow the crystallization to form, so you can get your crystal of the sodium chloride. This is the way of doing. Okay, you can use the same method also to produce the potassium salt from potassium hydroxide, ammonium salt from ammonium solution. Then we will be learning this one also, the whole thing, the year 10, 11 in details. Okay, so how you do in your year 9, can you see compared to year 10, 11? Okay, the book is just saying this. Place hydrochloric acid in the burette. Yeah, we need to put the alkaline here and not the acid here and the alkaline, because alkaline is so corrosive. Then the rubber here will be, will be spoiled. Okay, you spoil the thing. Okay, so make sure that 20 cm of sodium hydroxide alkaline here. Add a few drops of indicator. Okay, indicator you can add anything. Okay. Then add the acid from the burette slowly. Okay, you need to swirl the flag. Okay, moving, just swirl it. Okay. When the universal indicator change to green, you have produced a neutral solution. When this green, it means neutral solution. Add a spatula of the charcoal powder into the green solution. Mix it with the glass rod. The charcoal take the green color of the universal indicator out of the solution. Filter the mixture. Place the filter into the evaporated and heat gently. Safety. Careful. It may speed and burn you. Stop heating when you see some crystalline, or you can just pick up some of the solution and put it on the white type, cool white type, so that if the crystal form immediately, then you immediately turn on the heat and leave this for a few days, at least 1 day, 2 days, 3 days, so that you can form the crystal. Okay. So here, I need to show you the color of the universal indicator. This is in your year 10 book, but this one I think you can buy in the pharmacy. Okay, you can get this one. So when you dig in your paper, then you can compare. If something turned to this color, this blue, and you compare, yeah, exactly the same. So it's a pH 10. If you dig on the solution, you find that this is red. Oh, this is the acid. If you dig inside, that is a green color. That means it's a neutral 7. When the metal oxide dissolves in water, it forms an alkaline solution. Metal oxide are base. Okay, as I told you, dry form is called base, and the water solution is called alkaline. Sodium oxide plus water will become the sodium hydroxide, which is alkaline. So sodium oxide here is a dry form, or without water. Okay, so we call it a base, and then here is an alkaline. Some metal oxides are not soluble in water. For example, iron oxide, copper oxide. So they do not form alkalis. Okay, but if you, as you saw in UD in the 7.2b, they can still react with acid to form salt. Okay, so if they're not soluble in water, but they can, you can have them to make salt from them. For the oxide react with the acid. Okay, but be careful. The oxide there, we have 3 types of oxide. Okay, just to introduce to you before we end the class today. This is Mr. Henry Clement. Okay, for your year 9. If you like other things I can help, always let me know. Okay, comment in my Facebook, comment in my YouTube, so that I can try to answer you. Okay, or if you really want, go to Facebook and find the message and message me. I think, or I think open comment on the Facebook also okay, so we can allow some discussion there. So we have many types of oxide. Base oxide, which is a base, and then don't forget we also have the acidic oxide. Okay, this is not we want for this experiment, and also the amphoteric oxide. The 4th one is a neutral oxide. So we have 4 types. Okay, now. Okay, I think that's all for today. Okay. Lastly, we give you an example. If copper oxide plus sulfuric acid will become the copper, sulfate, and water. Okay. So for others, okay, sodium oxide plus the water will become sodium hydroxide. And then for the sodium, because this is so reactive, the sodium also can plus the water directly, so that to produce a sodium hydroxide. It's the same. Okay. So this is Mr. Henry Clement. Okay. This is a different colorful note also as well. If you need to look for some simple notes and complicated notes, we have a wide range of variation. You may purchase a simple note first, so that to cultivate your interest and make you like the subject. And then further, you can get more books and more complicated notes from us as well, so you can study more in more depth. Okay, and if you have done all the reading, then you can go to get some exercise or past paper from us as well. So I hope that it helps, and I hope that you are learning well. Thank you very much. This is Mr. Henry Clement wishing you a very good day today. Thank you. Bye.